everyone. My name is Madeline, and I would like to welcome you to our webinar for today. Today's topic is a webinar with Tekfen Engineering, Accelerate Feed with Concurrent Simulation, Estimation, and 3D Layouts. Before we start, joining us today would be Volkan Topalongu, process engineer from Tekfen Engineering, Enrique Guevara, who is a senior product marketing specialist from AspenTech, and joining us for the Q&A would be Sato Kazuyoshi, senior principal solution consultant, and Minky Huang, principal solution consultant, both from AspenTech. Before I hand over the presentation, I would like to offer a little more information about our speakers for today. Starting with Volkan, he's an accomplished process engineer with 3 years of experience in refinery and gas process industry. His expertise lies in process simulation, optimization, and technical economic analysis, conducting studies with AspenTech concurrent engineering tools. He earns a Bachelor of Science in Chemical Engineering, and right now he is also pursuing a Master's in Mechanical Engineering, focusing on chemical process simulation. Enrique is a chemical engineer with a degree from National Autonomous University of Mexico. He's been in AspenTech for 8 years. During the first 5 years, he worked as an engineering consultant and became the product champion for AspenTech safety and economic evaluation solutions. He's a product marketing specialist in the concurrent feed unit, focusing on engineering solutions with the goal of helping customers adopt a phased approach to their digital transformation journey. Sato serves as a senior principal solution consultant at AspenTech and is responsible for implementation support and consulting for the entire AspenTech's performance engineering suite. He started his career as a process engineer in a major engineering company and gained experience in process design, new process development, and commercialization studies for domestic and overseas plants. He holds a master's degree in chemical system engineering from the University of Tokyo. And finally, we have Minky. Minky is a principal solution consultant for Aspen One Engineering Products based in Seoul, Korea. Minky has a degree in chemical engineering, and after graduation, Minky joined GS E&C working as a basic design engineer involved in oil and gas, refinery, and petrochemical projects, and also working in the new business development team in DL Chemical. He has over 10 years of experience in engineering simulations. So with that, we will begin today's webinar.
Yes, just a quick overview about the topics we'll be covering in today's webinar. We're going to have a quick overview about what is concurrent engineering. This is something that Lee has been mentioning a couple of times so far. We're going to be just getting everyone up to speed about what is concurrent engineering and how it is able to accelerate project execution and how it can help you achieve faster delivery timeframes. And then we'll move on and showcase how Tekfen Engineering was able to leverage this solution, what was their specific experience, and how they were able to use this in two separate instances to bring benefits and accelerate the proposal stages. Last but not least, we will have some time dedicated for Q&A. And over here, I do want to remind people to please submit their questions as soon as you get them. The more questions, the earlier we see your question, the higher the possibility we'll have to answer it live. So I do encourage you to not wait until the end of the presentation and start submitting your questions alongside the slides that we'll be running. So with that said, I really just want to quickly bring everyone up to speed about what is concurrent engineering and how is AspenTech able to use all of these solutions that we deliver to customers to be able to bring all of these benefits. So AspenTech as a whole has this performance engineering suite, which is basically a very big family of solutions that cover a lot of the necessities or are able to solve a lot of the challenges that today's companies have. With all of these solutions, we are able to optimize CAPEX and accelerate the execution speed of new designs or the revamp of already existing processes. We can get innovative processes even faster, which also includes, of course, projects related to sustainability processes. We can also identify and remove bottlenecks so we can adopt or modify our operations and be able to optimize precisely their specs. And we're also able to seamlessly transfer information between several of the solutions so we can straight away reach a better design faster. So as part of performance engineering, we have, of course, concurrent engineering is a subset, just let's call it that way, a subset of our solutions that can integrate between themselves, that can communicate between themselves. And the intention of having all of these solutions working together is that we can have a whole bunch of multiple disciplines working at the same time, using the same solution, keeping consistency, and being able to reach a better design faster. So I'm going to show this quick diagram, and I don't want to scare people just by saying so many ideas at the same time. But this is basically a quick illustration about what is concurrent engineering. Concurrent engineering, of course, is something that can happen across multiple stages of engineering, from feasibility to detailed design. And of course, again, in a normal engineering process or a normal design process, we have a lot of disciplines working together, and ideally we want them to be consistent and be used and working together at the same time. So we have, as part of concurrent engineering, we have reliability analysis on the left. We also have process simulation. We have detailed equipment design. We have basic engineering for project deliverables. We have 3D layouts. We have cost estimation. And of course, we can move all of this information all the way towards detailed engineering. So the idea of concurrent engineering is that we have all of these different connectivities or different integration between all of these AspenTech solutions that allow us to, again, keep data consistent. The information we get from simulation can seamlessly go to the cost estimate or can seamlessly go to basic engineering for deliverables. And we are able to do this fast, reliably, and of course, consistently. So this is a little bit of an overview about what is concurrent engineering, and a little bit later we're going to be zooming in about and showing what part of this workflow was Tekfen able to use for their use cases. So before that, just I really want to use this information that I just gave about integration, about collaboration, and about a better workflow and a faster workflow to talk about how this integration is able to accelerate your speed. So of course, having all of these different disciplines or different engineering branches working together and keeping data consistent, we can have a better visibility of the overall project. Of course, we can have the process simulation on one side, but we can also have the 3D model on one side. So we're not only looking at the conditions of the process itself, but also the space, any kind of restrictions, any kind of space, cost, or material restrictions. We can be looking at all of them at the same time and be able to have a better and feasible design at a faster pace. We can also identify risk earlier. We can have better collaborations. We can seamlessly transfer information from one portion of the process to the next one, and of course avoid as much as possible of manual errors, typing errors, and of course have overall consistency and achieve overall consistency for an earlier decision making and overall obtaining better results at an early stage. So as I was saying, from this big workflow that I showcased a little bit earlier, for today's presentation, we're going to be focusing on these three: process simulation, cost estimation, and conceptual 3D layout. On today's use cases that Tekfen will present in a couple of minutes, they will show how they were able to use all of these three solutions individually, of course, for some specific cases. For example, how they were able to use a simulation to do equipment design, a column design, and then how they were able to transfer this information to cost estimate. Of course, be able to do some optioneering, some modifications, and answer questions that allow them to get a good estimate early in the process, early in the life cycle, and then how this estimate was also able to assist them to create a good layout, again, early in the life cycle that brought better visibility and showcase help them mitigate any kind of risks that could present down the line. So before I hand it over to Mr. Vulcan and show them their use cases, I just want to use a couple of minutes to bring everyone up to speed about these three solutions that I just highlighted. Of course, I think almost everyone will be familiar with our process simulation solutions, which include, of course, Aspen HYSYS and Aspen Plus. As you know, these are state-of-art process simulators that are able to pretty much simulate any kind of chemical or petrochemical process that we want to simulate. So we can use these two solutions to get all the design part out of the way and then we can use our cost estimation solutions, which is a consistent solution from the earliest stages to the latest stages, not only construction, but also operations and maintenance. And we're able to generate reliable cost estimates using a unique model-based cost estimation that, again, it's unique to AspenTech. This is something that uses already empirical information to, instead of just allocating percentages to piping, to instrumentation, to steel, and other material takeoffs. Instead, what AspenTech does is that it rigorously simulates how many pipes you will need, what are the size of these pipes, how many fittings does this pipe needs. Same goes with steel. How much steel do I have? Instead of going with a percentage, it actually designs how much steel or calculates how much steel we will require and uses this approach to generate reliable cost estimates. And on the other side, of course, we also have our 3D layout modeling tool. In this case, we're talking about Aspen OptiPlant 3D layout. And again, we can leverage data from simulation or from cost estimate to really quickly create an initial a status of a 3D layout. It requires very minimum inputs to start running. So in comparison with other detailed 3D layout tools or AutoCAD, for example, we will have a lot of information ready out of the box, and we will require very few inputs to start creating a very good a 3D layout. And we can also use use and test multiple configurations and use the engine that we have available in OptiPlant 3D layouts to calculate or create what we call auto-pipe layout. So given a list of connectivity, OptiPlant will be able to generate pipes and also route them accordingly and create an accurate and reliable route for all of these pipes. Of course, with several considerations. And we can leverage all of these three solutions together so we can see success in our overall design. So with this out of the way, I would like to hand it over to Mr. Volken. He will be presenting two use cases. I'll give it the stage to you.
Thank you very much for handing me over the presentation. Thank you, Lee, for introducing me. So today I will talk about the use cases of AspenTech tools at Tekfen Engineering, how we use them, how we leverage them, how we accelerated the combined simulation and estimation and 3D. So let's go ahead and continue. We will look at Tekfen, what we do in here, and then we will continue to the first case study, how we leverage HYSYS, ACC, OptiPlant all together with concurrently for early engineering. And then we will see the proposal, how we leveraged all these tools together for proposal stage. We will show that for the second case study. Next slide is Tekfen Holding is publicly listed holding in Istanbul Stock Exchange. We mainly do engineering, contracting, and procurement here on the left side, and we also mainly do we are in fertilizer industry, fertilizer production industry, chemical industry. The contracting group delivers turnkey solutions and with design and engineering, with manufacturing, process and storage equipment, with construction in different parts of the world, such as Qatar, Azerbaijan, Kazakhstan, and Turkey as well. We also have procurement services, export finance and procurement here. As Tekfen Engineering, we invest and execute. We have experience on each step and role here. As investor, we are operating in fertilizer industry, executed different projects in chemical sector. And as engineer, we are the biggest engineering group in Turkey. We have many reference projects in different sectors as Tekfen Engineering. As contractor, we are one of the biggest company in Turkey. And we have more than 67 years of experience in EPC and EPF executions. So after that, we can, I think, continue with the case study. First case study, we used HYSYS, Aspen Capital Cost Estimator, and OptiPlant altogether for saltwater stripping unit for a feed study, which took around 8 months. Here, as I said, the project duration was 8 months, and the main idea is to find the feed proposal cost at the end of this feed project for saltwater stripping unit. The case study objective is before starting the project, and then at the end of the project, we will see the cost differences at each stage, how much ACC and HYSYS got closer to the proposal cost, and we will compare the difference between them. Also, we will show how we leverage OptiPlant to find out piping lengths and 3D design, 3D layout. The process design part, we use HYSYS and optimized in HYSYS. We use rate-based column modeling. We use also HYSYS for hydraulics. For cost estimation part, we leveraged OptiPlant and Aspen Capital Cost Estimator. The column hydraulics, I think, is very useful, which is built-in tool for column hydraulic performance. And you can make detailed hydraulic calculations in HYSYS, which is embedded to the HYSYS. You can calculate and find the diameter of the column. You can optimize gas liquid traffic in here, and you can also monitor your changes as well. We also leverage rigorous rate-based stripping here for salvage stripping column. I think it eliminates the predicting the height of the column, which has embedded mass transfer and heat transfer models in it. So you can find the column height for equivalent to each stage. Also, the model that we used here for salvage stripping unit has included detailed reaction kinetics. So you are not, so you don't need to here find the kinetics for salvage stripping unit. Also, as I said, there is predefined reactions in the package itself. The model in here, there are a couple of models. Each model's interfacial area, mass heat transfer coefficient, and reaction holdup correlations altogether estimates your column height. So the integration part, I will discuss about how we integrated all these tools together. So the first part, as input data, we have feed and composition, also the design basis. After this, we have, as I described previously, rate-based distillation and optimization, and we also leverage example files embedded to the HYSYS. We also have some in-house programs, and we use standards. For in-house programs, we also use hydraulics part for the pipes as well. So as deliverables, we work other disciplines such as civil, instrument, and etc. We will discuss about later. For the cost estimation part, we will see the estimate progress time here from HYSYS to capital cost estimator. And then the deliverables, we will use some deliverables that we produce here for capital cost estimator as input data. Also, here we leverage OptiPlant to find the pipe length, proper pipe length, layout area, rec dimensions. And then, as you can see, we have an output from 3D layout, the automated piping. After that, we are preparing cost estimation report, as I show here. Let me discuss about the project states that we are using at Tekfen Engineering. As process, we start the project with previous projects and standards. After that, we issue process flow diagram PFD here for the second month. As you see, we start PNID at second month. And then we issue the data sheet and PNIDs for the third month. And then instrument electrical piping departments are all together, comes into the scene and we work together. And then we deliver these files to the process, mechanical and electrical departments. So after 5th month, civil continues to the project, and then project continues. As I show here, after the project goes and as expected, uncertainty goes down and the information increases as well. So the next slide, we will compare the cost estimation states. So here in this chart, you will see the data that we fed to the tool here. For example, HYSYS. If you use HYSYS, we put X here. If you use Go by PFD, we put X in here. There is no issued PFD here, which is minus. There is no issued PFD, and there is no data sheet for minus, for example. There is no optic piping used here. PNID, line list, and layouts not used in here. Also, the start part, we are at the start part of the project. What we do is in HYSYS, we open the Aspen Process Economics Analyzer button on, and then what we find is around 44% error with the proposal cost, right? So here what you see is the 5.3 million estimated cost at the end of the FEED project. As Tekfen Engineering, we worked this project for more than 7 months, 8 months. We find the 5.3 million euros cost. Here, as I said, there is the 44% difference when you open HYSYS cost tool. You will get 3 million euros. After this, as I said, actually the thing is here, we have no effort here. We haven't defined any process flow diagrams, information, etc. There is nothing. Just open the tools embedded cost part. You will see 3 million. After this, we deliver all those information to Aspen Capital Cost Estimator. We are still using Go by PFD information, and the project has not started yet. But the very surprising part is 15% difference with the TRC proposal cost, which is I think very accurate for this project, even it's not started. Next slide is we tried, we also leverage OptiPlant here. As you see, there is another 2% increase here. We are still using Go by. There is no work in here. What we did is we used pipe size information from OptiPlant to Aspen Capital Cost Estimator. After 2 months of work, we delivered process flow diagram, and then we prepared PFT, and the cost diverged a little bit because we deleted some equipment. And then, we revised the Aspen capital cost estimator accordingly. After that, we also used in this part OptiPlant. We have 5% increment here. And then what we did is for the third month, we used datasheet, issued PFT, information. If we use both of them, if we use a special datasheet from process department information, we have a 2% error in here, as you see. After using OptiPlant, we will also have another 5% increment, which takes 3% difference with the TIC proposal cost. After that, at the end of the project, if you use PNID, our PNIDs, our line lists, our layouts, without using OptiPlant, also we have issued datasheet and PFDs, we will diverge a little bit more from here. I think it is very acceptable costing here as well. As I said, we have this type of flow at Tekfen Engineering. As you can see, this is the gap. This is the stages when we use Aspen Capital Cost Estimator for each stage. Next slide is let's discuss about the results. We think using Aspen Capital Cost Estimator and OptiPlant together for early engineering phase is very beneficial because it accurately estimates cost, as I discussed before. I think it's very important before even starting the project, you will get a very decent amount of error. Also, after using the OptiPlant, you will foresee the layout field limitations in the field. You will find the accurate piping length and rect dimensions, which affects a lot. Also, we leverage automated piping from OptiPlant, and we worked for alternate piping. You can work with for alternate piping, routing solutions, and investigate the affected cost of the model. Also, having 3D model from the start, you can iterate throughout the project with your throughout the process. So the next case study, let's discuss about the proposal stage that we used all concurrent tools together for glycol dehydration unit. The scope is a capital cost estimation for glycol dehydration unit for EPF project, engineering, procurement, fabrication. In proposal stage, we leveraged Aspen OptiPlant for piping and 3D layout and higher piping cost accuracy. I think we can play the animation in here. As you see the automated piping, I think we can continue to the next slide. So the input data for this project, for this proposal project, was technical specification from the customer and the field photos, feed rates, compositions, earthquake regulations in the field, wind speed, site conditions. We also selected the material accordingly. We have a customer go by PNID. For the process design part, we used Aspen ISIS, multi-case here. Also, Aspen Design and Rating Tool, EDR, Exchanger Design and Rating Tool. For process flow diagram, we prepared PFD and MSD here. What we did is cost estimation is with capital cost estimator and OptiPlan together. For the multi-case part, I not only we used here ISIS, but also the multi-case as well. So here, what you can do is you can find your optimum number of trays for a tower, for a column. You can what you can do is you can work number of different cases in your ISIS configuration. You can see the sensitive points in your design, in your configuration, and what you can do is change the number of trays from Aspen ISIS and then create another different files for number of trays, and then run the Aspen multi-case for different parts for different compositions or feed rates, and then find the resulting composition. Here we have minimum and maximum compositions from our customer, as you can see on the left down part. We have minimum and maximum. There is no design part. We have only minimum and maximum. We don't know which part is the worst condition. So what we can do is we first find design composition, which is the worst condition for our process, for our design part. So what we do is run the multi-case for different types of number of trays, and then find the design composition accordingly. In here, the maximum amount of water in this feed stream will be the design composition. Also, you can work like lots of studies, more than 70,000 studies. The integration, the harmony in these tools is similar to the previous case study. Here we used design basis and field info. For ISIS, we use all those data to input to the ISIS, and then we have some deliverables from here. We have process flow diagram, heat and material balance, material selection diagram, and equipment sizing as well. After that, we find the design composition here, more than 70,000 cases. Also the optimum number of trays. We deliver all those information to Aspen Capital Cost Estimator. After this, we also use OptiPlant here as well. And then what we do is prepare the cost estimation report for our proposal department. Next slide is, let's discuss about the results and benefits of using these tools together. The integration enables rapid and accurate cost estimation for proposals in terms of weeks instead of months. I think it is very important. If you go and ask to the vendor, about the cost, they will ask you like couple of months. They will need couple of months to estimate the cost. But in here, you can have rapid cost estimation from Aspen Capital Cost Estimator. Here, all these integration took around 2 weeks to prepare this type of deliverables together, and then prepare the cost estimation report. I think using concurrently here, the tools make your preparation is very fast, makes very fast. So also, as we discussed in the previous case study, we have accurate cost estimation for engineering, procurement, fabrication proposals here, especially. We can also have layout and field. We can also foresee the layout and field limitations by implementing AspenTech plants here. You will get also the piping lengths that you need for cost estimation. Also, if you change the feed rates or so, if you change the composition, etc., you can, since it's very integrated tools together with HYSYS and OptiPlant, you can make seamless connection between them and deliver all those data from HYSYS to OptiPlant. I think also conceptualizing 3D model increases proposal success, which is very important for a company. So I think that was it. Thank you.
All right, thank you very much, Volkan. So yeah, I mean, basically, just to recap the story that Volkan presented just now, he was able to leverage concurrent engineering for two separate use cases, sour water stripping and glycol dehydration, which are a little bit different in terms of the industry that we're talking about. But at the end of the day, he was able to use the same solutions to in different methodologies to optimize the simulation part, optimize the operating conditions to reach the desired outcomes that we wanted from a thermodynamic point of view, as well as getting all of this information all the way to the cost estimation group, so we can use this unique model estimation methodology that we have in AspenTech to prevent going with vendors or to basically just a better result faster. You were able to see this on the first use case that Volkan presented, just without just by using HYSYS and its integrated module for automatic economic evaluation. He was able to get a number close to with a 44% error, right? But as soon as he was able to integrate more and more information, he quickly jumped in just a couple of months from an initial estimate, which is just a ballpark result, all the way to something that was as close as 5% error. So I think this speaks about the value of having this consistency, having this integration between the solutions, of course, having the ability of routing pipes and using real quantities or realistic quantities in our cost estimate instead of just running with defaults or instead of just running with approximations. We can get very good results very fast in the life cycle, and of course use this information to make better decisions. So alongside Tekfen stories, we have some other stories that have been presented. We have some content available in them. You can find them in our website. We have Exxon, ENI, Black & Beach, Toyo, Yes ENC. So some newer stories, some stories that leverage all of these integration capabilities that we have in concurrent engineering.
So now we will transition to the Q&A portion of our webinar. You can continue to submit your questions in the Q&A panel located on the bottom right corner of your screen. And with that, we will kickstart the Q&A. Over to you, Sato-san. Sato-san, you're on mute.
Okay, sorry. Yeah, so we are receiving some questions, so please free to ask a question in the Q&A chat box. So question number 1 is, how can I learn about sizing of equipment efficiently and estimate the optimum pricing in both commissioning and retrofitting stage? Yes, so the cost estimation for a greenfield project and brownfield project is different. So in our cost estimation tool, we have some option for retrofitting stage. For example, if you like to estimate the equipment costing, so there is a installation option, and you can estimate the cost of demolish of equipment and piping if you are in retrofitting stage. And also in our 3D layout tool, OptiPlant. So in this week, we released the new version of version 15. So I recommend you to install the newer version as soon. So in version 15 in OptiPlant, so there is a auto layout function, and generative AI can create the plot plan for you based on the equipment list and piping list. And in that auto layout function, so you can specify which equipment is existing and which equipment is new, and then the tool can give you the new plot plan. So we have several functions which fit to retrofit project. I hope it can get answering the question. And the next question is how to verify control valve and pump calculation from manufacturer with Aspen. Okay, so I will take care of this question. So in Aspen Plus and HiSys, there is a pump module and also the piping module. So you can calculate the pressure drop and fluid velocity by using the piping model. And you can calculate NPSH or pump head within the process simulation. Okay, and next, so Minky, can you choose some of the question and can you answer?
Okay, including the second question, the verifying control valve and pump calculation. Yes, you can verify the control valve manufacturer data. You can enter the data from vendors with table, or you can select the what vendors calculation method. So you can select the valve calculation, and you can verify the available CV or other parameters for pressure drop calculation. And there are some another questions from Q&A panel. One is what makes this different from others? Yes, in AspenTech Concurrent Engineering Solution, we have from process simulation to cost estimation in the same same program suite. So you can use our solution within one single process stream. However, in case of others, you have to send the data with Excel or other kind of things. So during this handling, there is some human errors might be occur. So using our solution, it you can less make a mistake with human errors. So there is another questions from here. Okay. Let me check.
Okay, so I will answer the other question next. So the question is how process simulation can be synchronized with RAM simulation. So we have RAM simulator Aspen Fidelis. So at this moment, the process simulator and Fidelis cannot exchange the data, but that will be our future plan. And next question is, do we start concurrent engineering as early as front-end loading 2? Yes, so many customers start to use our concurrent solution at front-end loading 2, which is conceptual design stage. But also many customers use our concurrent engineering solution earlier stage, like front-end loading 1 for feasibility study. So if you early our concurrent solution in early stage, you can visualize your plan in aspect of cost and also in aspect of layout plot plan. So multiple discipline engineer can share the image of the project. So yeah, so depends on the project stage. You can compare several options, or you can use our solution to reduce the plant cost and reduce the bulk materials. So you can utilize in many stages from earliest to front feed stage. Next.
Next thing
Lindsay,
is,
can you go
yes.
next?
What does ACC stand for? ACC is Aspen Capital Cost Estimator. That is, what is ACC, and it is not related to AACE. But however, ACCE is widely used for estimating the cost. So if we use our ACCE, it should reduce man-hour to estimating in early stage of project. So ACC might be helpful to reduce man-hour, and you can get more accuracy if you spend same time for the project. And next one is if you using our solution, including HYSYS Aspen Plus and ABE and other solutions, you can reduce your engineering time to build your data sheets or PFD and PNID, because ABE is another solution to handle all of data from HYSYS or Aspen Plus. So if you are interested in the document control using our solution, please contact us and we will send the brochure or some presentation material to you. And another things, can it estimate the minimum number of the equipment required in process and the associated cost? The minimum number is not a big deal of using cost estimator, because you are modeling the process using HYSYS or Aspen Plus. All of information from the process simulator goes to ACCE, capital cost estimator. So you can estimate the equipment cost with our ACCE solution. So there is no limitation of minimum equipment for the process.
Okay, so the next question is there any course where it sorry.
And another question is kind of CCUS. So yes, using our concurrent engineering solution, you can get some information in early stage, including in case of CCUS, you have to consider the amine system or some physical solvent system to capture the carbon. During this simulation, you can choose rate-based simulation for chemical reactions using amine. So that means you can calculate the column internals or all of systems hidden material balance more accurately compared with only using efficient model. For this, you can size the column or the reboiler or other equipment much more precisely. That helps you calculate the overall cost of the project. So there are some carbon capture references. So we will send the references or use cases for carbon capture system using our Aspen Plus and Aspen Capital Cost Estimator.
Okay, thank you. So next questions. So are there any case where AI system have been used in this process? So each of our solution is embedded AI. So you can utilize the hybrid modeling in Aspen Plus or HiSys, and also our 3D layout tool has an AI capability to route the piping and to do the layout generation. And next.
Another question is kind of hallucination of AI. So in case of our AI, that means not the publicated AI, that is industrial AI. So you have to choose the proper data to learn the machine to get some data. So during this process, you can check what data should be used for making AI model. So the hallucination problem might be lesser than the publications such as ChatGPT or Gemini. And let me check another questions.
Yeah. So another question is there any course where it emphasizes on the interface data transfer between ACCE, HiSys, OptiPlant, or you get to be using all the program above based on like project? So we have some training courses. So in OptiPlan training, it covers the integration between ACCE and OptiPlan. Yeah, I think that at this moment that all we have other training. And the other question is,
And in general, using the Aspen Capital Cost Estimator, each company should calibrate the cost index or unit base for each company's cost base. Because as per AspenTech gathers some cost information regularly, however, it cannot reflect all of companies' own cost base. So if a company wanted to use ACC for using proposal stage, the company should calibrate the result of default from ACC to meet company's own cost base. So there are some questions about the references or some examples of ACC. We provide some reference projects in the sample project, but however, you have to check the real costs of each equipment and have to calibrate for own cost data. And there's some another question about the EDR. Yes, there are some competitor of HTRI. Aspen EDR also widely used for design, rating, or simulating the heat exchangers. Especially Tekfen heat exchanger, Aspen EDR is widely used for rating the result of vendors' calculation. So, and also there are some very big advantage of using EDR to integrate in the HiSys or Aspen Plus, because as you have some experiences using integration, some simulator with HTRI, there are some input-output delays. But however, if you're using EDR, there are a lack of sending information from HiSys to EDR or Aspen Plus to EDR, and EDR2 simulator is very fast, so you can get some very easily approach the rating of the heat exchanger and get some heat trains performance easily. That is EDR's advantage of the compare with competitors.
Okay, so next question is, can you just briefly describe the process of design and economic evaluation for any chemical process using Aspen Plus used for simulation and Aspen economic cost estimator? So based on the project design basis, first you need to create a process simulation model based on the production rate and the reaction condition or required the purity of the product. So after you build up the process simulation, you integrate the equipment designing tool with process simulation. So you can design the heat exchanger by integrating EDR with Aspen Plus or HYSYS, and also the column diameter and height can be calculated within the process simulation. For some equipment, you can integrate your own equipment siting tool or with process simulator. So after you design the equipment, you can export the data process simulator to capital cost estimator to estimate the project cost. So in general, so in process simulator, the offsite facility like a tank or utility facility like a cooling tower or boiler are not included in the process simulation. So I recommend, so you additionally input the offsite and utility facility within economic estimation tool, then you can get more accurate cost estimation. Yeah, so that is a workflow. And also, so Aspen capital cost estimator will generate the volume of piping. But if you can get more accurate piping volume, you can export the data. So in process simulator, there is a piping connectivity data. So you can export the piping data to OptiPlant. And within OptiPlant, you can route the piping, then you can get more accurate piping volume from OptiPlant, and you can import that data into Aspen capital cost estimator. So based on the what accuracy you want to achieve, the workflow will be slightly different, but that will be the general workflow.
And there are some another question, some library for calibrate with the reference projects. Unfortunately, there is no library for calibration without reference projects, because as you know, if for example, one single vessel, if some EPC company or some owner operator company have different purchasing power, so company or user have to calibrate with reference projects. With the reference projects, there you can select 5 different regions, including the Middle East, Japan, and Europe, and USA, and UK. So in that region, AspenTech gather more data from the with some collaborative company. So you can get some data and get some cost estimation results from that 5 region. You can get some reference data. But however, if you are considering another company or another city, you can use decision analyzer. But however, you have to check the index of each city and each city and each capacity. So I recommend at first you use our solution, the ACCE, and check the weight of each equipment. Then you can calibrate the costs from the existing project and make the template for next project. That is my suggestion to use ACCE to reduce man-hour for the next project. And another
Okay.
question is, the hydraulic calculation is required for using OptiPlant? Yes, you have to know the size of piping because OptiPlant require the connections and you have to know the each line's pipe ID. Then the OptiPlan 3D calculate the routing of each nozzle or each point to another point. Then you can use this kind of information for estimating the cost. So you should know the pipe size of each nozzle or each lines.
Okay, so I will add some more. So within Aspen Plus or HYSYS, so you can utilize APEA to size the piping roughly. So when you activate APEA, the all line sizing will be calculated based on the equipment type or capacity of the equipment. So that is the most easiest way to roughly estimate the piping size, and you can export that data to OptiPlan. And the other way is in Aspen HYSYS, there is a line sizing utility. So based on when you use that line sizing utility, you can decide the size based on the velocity and pressure drop per 100 meter. So yeah, so there are several ways to do hydraulic calculation easily.
And another question is, how many tokens are required for AspenTech concurrent engineering solution? That answer is maximum 41 tokens for ACCE and 14 tokens for HYSYS and might be 9 tokens for EDR, but it is not using at the same time. So if you are considered one user for simulation of process and checking the EDR, and finally OptiPlan 3D and ACC might be 41 token is enough to one user for overall the field projects. But however, it depends on how many engineers are assigned to each stage. For example, 3 engineers for process simulation, or 2 engineers for EDR, or other kind of things. It can be changed to the maximum token required. But however, for one user, the ACCE, Aspen Capital Cost Estimator, the largest token consumption is 41 token. And where can we access the APEA? You can find the dashboard in the process simulator. So you can see in the just below the menu, you can check the four dashboard. For example, the APEA and Aspen EDR and energy analysis and CO2 analysis. So you can find the green button of the APEA in process simulators. And there are some another question about the API and connecting to Pythons. I'm not sure, and we have to check the possibility of to connect the information from ACCE to Python. As you know, HiSys and Aspen Plus, the COM interface can send the result or the data from HiSys and Aspen Plus to another programming solutions, Python or Visual Basic. So you can connect, but however, we have to check the ACCE.
Okay, thank you, Minky. So, we end up the time. So we like to close the Q&A session now. So if you have a further question, please free to contact AspenTech. So we have customer support team, and you can, when you use the software, and you have a question, you can contact us free. Please free to contact us for further question and discussion. And yeah. Okay.
Thank you, Sato-san, and thank you, Minky, and thank you to all the attendees for attending today's webinar. An on-demand version of this webcast will be made available in the coming days and will be emailed to everyone here. Thank you so much and have a good day.